Recently at work, I had to drain some water from tanks into this pail. Since the pail is located below the drain, we have to pump the water out of this pail into the drain. I could just do this manually by turning the pump on and off, but I thought it would be really neat to have it automatically turn on when the water level reaches a certain point and shut off before the water ran out of the tank. It's important to have the pump shut off before all the water drains out of the tank, because otherwise the pump will basically burn itself up. At first we thought of using a single float as a switch to turn the pump off when the water reached a low level. However, when the pump would shut off, the water in the tube would run back into the tank and push the float up again, turning the pump on. The pump would just sit there going on and off, on and off. There are two ways around this. The one is when the float bottoms out, a timer starts and the pump pumps for a little while longer before it shuts off. The second way is to use two floats, a high and a low float. When the water reaches the top float, the pump turns on, and when the water bottoms out the bottom float, the pump shuts off. I found this very simple design online to control the pump. It involves a 12-volt power supply, a 12-volt relay, and an 120-volt relay to run the pump. As water rises in the tank, it raises the bottom float and closes it. This sends 12 volts to the common pin of the 12-volt relay. As the water continues to rise, it raises the top float and closes that switch. This sends 12 volts to the coil of the 12-volt relay, energizing it and closing the connection between the common and the normally open pin. The normally open pin is connected to the 120-volt relay, and this powers up the pump. It's also connected back to the relay coil. This is important because as water is pumped out of the container and the top float falls and that switch opens, the relay will remain energized because of the power flowing through the bottom float switch, through the common and normally open pins, and back to the coil. Finally, when the water level falls low enough that the bottom float opens, all power is cut off to the relay, which cuts off all power to the pump. If water in the tube falls back into the container and the bottom float closes, the relay will not energize. I did a little digging online, found this design, and then ordered a bunch of parts to add to this tank to make this pump controller. Let's do this. Here's everything you'll need for this build. A 12-volt relay, a diode, 4 screw terminals, some standoffs and screws, a circuit board, a 1/4-inch bolt, nuts and washers, a solid state relay, 120 volt, a dual level float switch or 2 float switches, 4 zip ties, a 12-volt DC power supply, a fountain pump, and a large project enclosure. You'll also need some short lengths of wire, 16 gauge is fine. The first thing you'll want to do is strip back a section of wire on the pump wire, close to the pump. You'll want to cut the white wire and strip back the ends. I also stripped back the green and the black wires. You don't want to strip back the green wire though. I had to tape this up and that was kind of a pain. Cut the power cord for the 12-volt power supply close to the power supply. Strip back these wires. The one gets attached to the black section of exposed wire on the pump power cord. Take 2 pieces of white wire, strip back the ends, attach the one to the white wire on the plug side of the pump cord. The other black wire from the power supply wire gets attached there as well. Attach the other white wire to the second cut white wire. Clean it up with shrink tape and tape everything else. This is kind of a pain and it isn't the nicest, but push everything together as best you can. I use a rubberized tape to cover everything up after it's taped. I like this tape a lot. It creates a nice weather-tight seal and it looks better than an electrical tape. Attach the standoffs to the circuit board. You'll have to drill a hole in the circuit board for the common pin of the relay. The diode connects across the coil of the relay. Bend this and put it in place. When the relay and diode are in place, solder everything onto the board. Next, you'll want to place the screw terminals. 4 of those go together on the one end to connect to the float switch. 2 go on the one end of the relay, and the other 2 I have on the side of the relay. Solder everything onto the board and connect the circuitry required. The best practice we found for this was to tin each section of the board and then connect the bubbles of solder to create the lines. We did make a mistake, so we had to reheat a section and scrape that off with a screwdriver. You'll need to cut a hole in the side of the enclosure for the power supply cord. Next, we wanted to cut grills into the top and bottom of the box to prevent the whole system from overheating. These can be cut with a Dremel tool, cleaned up with a file, and sanded. Cut the wire on the DC side of the DC power supply, strip it back, attach these wires to the DC voltage power supply terminals on the board. The power supply box can be zip tied into the enclosure. Next, the circuit board is mounted, and then the solid state relay is attached using the 1/4-inch bolts. Thread the 2 white wires into the box. Cut these wires, strip back the ends, and attach them to the 120 volt side of the solid state relay. We'll need 2 wires from the relay outputs of the circuit board to control the solid state relay. Make sure to connect the polarity correctly on these. Next, the float switch is put into the bucket and secured. The wires are threaded into the box before being attached to the 4 terminal screws. For my float switch, I found that the 2 black wires were for the bottom float and the 2 red wires were for the top float. Finally, the pump is placed into the bucket and we are done. We tested the system by dumping water into the bucket. You'll see as the bottom float rises, the pump does not turn on. However, when the top float rises, the pump turns on and begins to pump water out of the bucket. When the bottom float does finally fall and the pump shuts off, the water flowing down the tube back into the bucket does not turn the pump on. You could use this for all sorts of drainage applications, whether it's a sump pump or some sort of water control system you have for your garden or whatever. I just thought it was a super simple way of controlling a pump, and as always, subscribe. I'll link somewhere. Check back a lot. I'll be building quite a few things here coming up, and that's it.